I'm hoping that the talk is going to give everyone just a more in-depth overview into how SSH works internally and how we can improve developer productivity with SSH. Just a bit of context about myself. My name is Moses. Oh, I didn't actually put my name on the slides, but you might be able to guess my name from the Gmail address. Moses Koledoye is my name. And I'm a senior engineer. I'm a senior SRE at Google, senior software engineer and SRE at Google. I've been at Google for 4 years, and I think part of my time at Google, I've worked on proxies, which could be SSH proxies, HTTP proxy, whatever it is, all types of proxies. And yeah, I worked. I think the last my first 3 years at Google, I was tech lead for one of the teams that runs the internal proxy, and then the Google Cloud, one of the Google Cloud offering proxies. It's called IAP, Identity Aware Proxy. Some of you might be familiar with that. These days, I've moved teams. I'm TL tech lead for a different team. We use SSH, but not as extensively as the previous team. I've also been able to build stuff around SSH, say, building SOC servers that go from Google production to Google Cloud, or that go from the external internet into Google Corp, and then go into Google Prod, and then go into Google Cloud. So all bits and pieces of like interesting stuff with SSH. I think SSH is very desirable because if you think about different network environments, so you could think about your workplace. You might have like an external internet, which is the public internet. You might have your internal corporate network, and you might have a different production network, right? And being able to glue all of those together and be able to guarantee a lot of security, because usually security is the underlying thing that we all want to have guarantees for, right? You want to be sure that no one's going to be able to attack or snoop on your traffic. You want to be sure that you wouldn't experience a man in the middle attack. So let's say someone is able to hijack one of the boxes, or I'd say boxes or intermediate machines in your network. You still want to be sure that your communication will be secure. So this is why SSH for me is one of the key primary protocols, I think, that has been developed in the last couple of years. I feel like it's a monster of a protocol, right? And the better you get at using SSH, the more productive I think you could be. And understanding the internals of SSH also helps you understand in general how systems work, how network systems work in general, right? So very quickly, it's a 90-minute, I have 90 minutes assigned, so I may not use all of the 90 minutes, or I may go slightly above it, depending on how the conversation goes. Feel free to stop me in between. Use the raise hand feature. I will stop. I will take questions. If you have extra comments to make, please try not to interrupt if you are not having a question. If you have comments to make, you can leave them as comments, and I will try to call them out. But yeah, if you do have questions, feel free to raise your hand. I will stop and address the questions. I'll have dedicated time for question and answers at the very end. So there's also that. So very quickly on the outline, we've got an introduction to SSH. So if you've never used SSH before, or you've only, I remember when I saw the calendar invite, something said, if you've only used SSH for GitHub, or is it calendar or Twitter? There was a tweet. I saw the tweet like a day after it came out. And then I was like, hey, wait, what does that mean? SSH or GitHub? And I just remember, because we don't use GitHub. I mean, primarily we don't use GitHub at Google. I've been at Google for 4 years. I don't remember the last time that I used GitHub. I've used GitHub before I joined. And I remember that, yes, if you wanted to like clone a repo or do some things, you need to like copy some public keys and do some things with like SSH into some GitHub thing. And yeah, I guess that's the context behind that. But I think my intention today is to make it as generic as possible. You have a bare Linux box. So you've installed Debian, you've installed Ubuntu, you've installed anything, and you want to SSH into that machine from your local machine. Or you have a machine that's embedded in a private network, and you want to go through intermediate machines to reach that machine. So by private network, I mean the machine does not have a public IP address. If you're familiar with how the internet works, you might have a network that's inside of a private network, which means it doesn't have a public facing IP address. which means only machines inside that network can talk to that machine. And if you have access to a machine that is in that network, that has access to the public internet, you can jump. We'll get there eventually. Call them jump hosts. You can jump to the network inside the machine if you have the authentication properly set up. So all of those will happen in the live demo. I'm going to spend a lot of time in the live demo. Things might go wrong. So if you're familiar with live demos, I've done lots of live demos before. Sometimes things go wrong. I think that the point that I will try to make here is that the idea is the fundamental thing. Just guarantee that it works. Just take it for granted that any command or anything, I've tried them before, they've worked, but if they don't work now, I don't know, but hopefully everything will work. So the first thing I will start with, how do you, in the live demo, how do you configure your Linux box or machine with SSH, which is basically open SSH. So there are multiple versions of SSH, or multiple variants of the SSH implementation, that OpenSSH is the most supported. If you install Linux today, OpenSSH will be installed directly. So you really don't need to install, but sometimes you need to configure. If you're a sysadmin or you're an SRE, you might need to configure your machine for special cases. Port forwarding is something that I will also run through, which is the thing I talked about earlier. You need to run through a host, you need to access a service on a different machine. So let's say a server is running on another machine, and you want to sort of fake, or you want to make a port on your machine fake or forward traffic directly from a port on your machine to that network service. It could be a database, it could be an HTTP server, it could be a mail server. I'm going to just run through that in the live demo as well. X forwarding, I may or may not. You need to install Xterm. So I may or may not go through X forwarding. And then the SSH Internals, I will just do a dump of the system calls that happen when you invoke an SSH call. And then we'll try to walk through the syscalls. If you're familiar with the Linux operating system, some of the things might stick out to you, but then it will help you understand better how things happen behind the scenes with SSH. The networking bits as well, I might try to do a TCP dump at some point so you see what the packets look like. They're actually encrypted, so you can't read them. We could do a TCP dump of an HTTP traffic first, just to show us what it looks like if you can snoop on plain text. I will also go to the authentication authorization bit. So auth-n-ZEM means authentication and authorization. Authentication is when you try to present yourself and say, I am me, I am this person. Right, so you want to actually put an identity to the person, and authorization is what is that person allowed to do. So after you've authenticated the person, what privileges do they have on the machine they're SSHing into? Then I will talk about optimizations and pitfalls. What are things you should look out for when you're setting up SSH? I will run through optimizations that you can use to speed up. If say you're in a remote place, you're far away, and you need to set up SSH in a way that's more efficient or it's faster. I will talk through a bit of that, and then we'll run through the Q&A. So again, feel free to stop me if you have questions. I will stop, use the raise hand feature, and I'll be happy to stop if there are questions. So again, the audience is engineers who want to be more productive with SSH, sysadmins who want to add in their SSH clients or servers, and maybe newbies and everyone else. I say maybe because some of the terms will be very technical, but have no worry. You can always read up. I think the whole point is just to give you an overview. I don't expect that everything is going to be unraveled here. I also hope to learn. If people have ideas, just feel free to share them, and I hope also to learn from you guys if you have particular use cases or interesting use cases with SSH. So very quickly, SSH, secure shell, it's a portmanteau word, is a protocol, a cryptographic protocol for secure remote login and for operating network services over an insecure network. And that's the emphasis here, right? If you have a secure network, you probably don't need SSH, right? But either you have a secure or an insecure network, it covers both cases, right? You want to do remote login to a machine, and you want to be sure that the login is going to be secure. SSH guarantees that. And even if the online network is not secure, so you have to go to the public internet, you have to go to your ISP, whatever it is, MTN, Vodafone, Telcom, whatever underlying network you have, SSH guarantees that the that the communication is going to be secure. And the architecture is basically client server. So you always have a server on the other side you're trying to log into, and you have a client on your side, right? So the server runs as a daemon. If you're familiar with the Linux operating system, some things are daemonized, so they run perpetually. And then you have a client on the other side that actually does the, you invoke the client, and then it tries to drop you into a remote login session. Or you could also use it to internet-work with other network services on the remote box. So very quickly, can't click on stuff here. I'm actually trying to click on this link here, but apparently I can't. So let me try. See, oh yeah, now I can click it. So this is the RFC. If you're familiar with RFCs, there are requests for comments. This is how a lot of TCP/IP protocols were developed with RFCs. The internet basically was built off of RFCs. And you can see that this was proposed in 2006. And it says the Secure Shell Transport Layer Protocol. So I've already talked about how this is, it's just copy-paste of this text. But then in the extended form, you can see that it says the Secure SSH Transport Layer Protocol, which typically runs on TCP/IP. So it's a TCP/IP based protocol, right? It's not UDP based. The protocol can be used as a basis for a number of secure network services. It provides strong encryption. I think this is the most desirable, one of the most desirable features of SSH is that the encryption is very strong. I will talk about the different layers of encryption that you have with SSH as we go on. It allows server authentication, so you can authenticate as a user. You're not just guaranteeing that the communication is secure, but the person who has access to it must have some credentials. They must prove that they are who they are, and there's also integrity protection. Right, so there's a way for you to guarantee that packets are not dropped, and if they're dropped, they can be retransmitted. TCP/IP already has a bit of that, retransmission with TCP. You do guarantee that packets can be retransmitted, but as an extension to that, built as an extra integrity protection, SSH has its own way of checking that its own packets have not been corrupted, so to speak. I will talk a bit about that as we go on as well. It may also provide compression. I think this is usually useful if you're running X forwarding, which is the terminal interface. Sorry, the windowing interface. Yeah, is there a question? Can we get a link to the slides after the sessions? Yes, I will share a link to the slides. And the cryptography part basically does key exchange method, which means before you start communicating, there's a way that we exchange keys between ourselves and negotiate how we actually want to exchange keys. I will run through that as we go on. Just keep that in mind. There's public key algorithm used for authentication, and which is also used as part of the key exchange procedure. There's symmetric encryption, which is much more lightweight than public key encryption, which makes the encryption and decryption of in-flight data very fast. But this happens behind the scenes. This happens after we have negotiated a key exchange. Message authentication, which I talked about earlier, is used for integrity protection. We will talk a bit about that, and as we go into the innards, I will also talk about that. And then there are hash algorithms as well that can help you protect your, say, your private key or your known host file or different types of things. There's a lot of things that come with SSH. If you're not familiar with the Diffie-Hellman key exchange, I'm not going to go into that, but this is basically the underlying framework with which we start from public key. We do the key exchange, we negotiate how we want to do our cryptography, and then we go into symmetric encryption, right? So if you want to read up more, you can read about the Diffie-Hellman key exchange. There's going to be a lot of curve, elliptic curve, digital signature algorithm, yada yada, Edward something something. You will see them later on in the cipher suites that SSH offers, and I think understanding how Diffie-Hellman key exchange works is a very good base for you to understand how encryption actually works behind the scenes. But I wouldn't go into all of that. So as an overview, let's go back to the slides. As an overview, we have this diagram here. I hope it's representative enough. So on one machine, I have the client. I have the client installed on one machine, and I have the daemon, the server, running on another machine. I have client configs, I have client keys. Remember we talked about public key cryptography earlier on. The client config is just a way to tell how the client should configure itself. And we have the server configs, which is also the way the server configures itself, and we have server keys as well. And then we have an SSH agent, which you may or may not use, but I will show why you should use the SSH agent as much as possible. For each connection, you can have multiple channels, and channels have different types. So you might have a channel where you start a session, a shell session has one channel. The user agent will also run in its own channel. And then you might also have port forwarding, which also has its own channel, and everything happens on the same TCP connection, right? So imagine you have one TCP connection. A TCP connection, you could imagine like a tuple. You have a tuple of source IP address, source port, and then you have destination IP address and destination port, and you have that tuple. And then let's assume that tuple defines a connection. On top of that connection, you can have multiple channels multiplexed, and the protocol itself guarantees that one channel will not snub out or will not overstab the connection. So if you open a shell session on a remote machine, and you're trying to port forward from that machine, from your local machine to that machine, the port forwarding channel and the shell session channel are going to be multiplexed over the same TCP connection, right? I will talk about how you can manage. It's possible that if you create a connection, or if you try to SSH into one machine, and you try to recreate another connection to that same machine, you're going to have two connections, right? It's possible to merge or reuse connections, and I will talk about that in optimizations. Any questions so far?
Yeah, you can go on. No, just go.
All right, cool. I am seeing. All right, so I will go on straight. I think this is the part we'll go into. Yeah, so I'll just talk quickly about the cryptography path. SSH uses public key or cryptography in general extensively. So SSH uses strong cryptography, and part of that cryptography, you start with a key exchange. I talked about that earlier, where you have a public key. You use public key cryptography, which means you have a key pair. If you're familiar with public key cryptography, you have a private key and a public key. Your public key, you can share that with anybody. And the public key is usually used to encrypt the data. So if we have Bob and Alice, which is the usual examples that you have, Bob has a key pair, a public key and a private key. Alice has a public key and a private key as well. Now, Bob and Alice are trying to communicate. What basically happens is Bob gives Alice his own public key, and Alice gives Bob his public key. And what happens is the both of them try to encrypt. When they start to communicate, Bob will encrypt data that he's trying to send to Alice using Alice's public key, and Alice will try to encrypt the data that she has from that she's trying to send to Bob using Bob's public key. And the way that the both of them can decrypt is using their private keys. So since data was encrypted using their respective public keys, they can decrypt the data using their private keys. This is basically how, fundamentally, in a nutshell, how public key cryptography works. But since that's really expensive, because of the whole infrastructure behind public key cryptography, having to like encrypt, decrypt with different key pairs, it's quite expensive. So what SSH basically does is initially you negotiate a key exchange. You pick a cipher. It could be ECDSA. It could be some other encryption algorithm, and then you use that to set up symmetric encryption, which both the server and the clients, they both negotiate, right? So once you've set up symmetric encryption, then you have to authenticate the user. That also happens with public key cryptography. So you can authenticate the user using a password, which is discouraged. By password, I mean, if you're familiar with how Linux works, you have a username and a password, right? If I'm trying to log into a server or a Linux machine, a server that has a Linux machine running, a Linux operating system running on it, I can log in locally to that server using my username and my password. It applies the same way with SSH. If I try to SSH to a remote machine, I can log in using credentials of a user, or username and a password that's acceptable on that machine. But this is usually discouraged because it's not robust enough. Public key is the preferable way to do authentication, right? So just basically take your local machine's public key and copy it to a directory or a path, which I will talk about later, on the remote machine, and that grants you access from the local machine to your remote machine. Obviously, you first of all need to generate your public key. You need to generate your key pairs. SSH, the client comes with a SSH keygen binary that allows you to do that. And then I broached lightly on the integrity part. I said the SSH also has a way that it allows users to guarantee integrity of the packets that are sent. And this is achieved by message authentication code, which is basically it's if you're familiar with how you do error correction. It's similar to error correction, not the same, but you will try and sign the data, and then you append the signature to the data you're sending. And then on the other side, when you receive the data, you try to check that the data, you pad the code, the authentication code of the message with the message. And then on the other side, you try to check that the message has not been tampered with. That is, you try to recheck that the code actually matches the hash of the message, again, on the receiver side. And if you go into DigitalOcean, they have a very in-depth way explanation of how encryption works, how you set up the connection, yada, yada, yada. I'm not going to go into all of that. I feel like I've talked a lot about how encryption works behind the scenes. Any questions so far? Am I going too fast? Am I being too technical? Any comments, any feedback? Or I just continue? All right, I see thumbs up. All right, we continue. So I start the live demo now. Context, I've set up 3 machines. I have a proxy server. It's an empty Linux box. There's nothing on it. There's a web server, also an empty Linux box. We're going to write a web server on this call very quickly. And a database server, which I'm not going to set up because that might take time, installing my SQL and all of that stuff might take a lot of time. So what I'm going to try and do on this call is I will, first of all, try to set up access to the proxy server. The web server is going to be behind the proxy server, which means I have a reverse proxy, if you're familiar with proxies. So the web server will not have a public IP address, and I will try to SSH into the web server, which does not have a public IP address, right? And I will try to do some, just to show how SSH works. I'll try to jump through the proxy server into the web server, show how I can reuse my authentication to the proxy server on the web server. And I'm also going to try to forward ports from my web server. So I have a web server running at a certain port, which we're going to write. The web server is running at that port, and I will try to make my local machine think that the web server is actually running locally by forwarding a port from my local machine to the web server through the proxy server. So follow me as I go on. Things might get a bit technical. Stop me, raise a hand, ask questions. Don't be shy. I don't think any question is stupid. And feel free to make comments, to leave comments also as we go on. I'm also looking to learn from you all. All right, very quickly. Cloud Console. So we'll be using Google Cloud, unsurprisingly. So let's go on Google Cloud. I mean, I could use AWS as well, but you have to.
Of course.
All right, so this is my Google Cloud Console. I will go into a project I've created specially for this. And can everyone see this? I assume yes. I can make this slightly bigger. Okay, so you can see that we have a database server that I've stopped. It's not running. I have a proxy server. Pay attention. We have an IP address. So I'll just talk about how this space is networked before we dive into everything, because I think this is important for us to understand what I'm going to be doing in the next steps. So we have a database server. It's not running, so we're not going to be doing that. I leave that as an exercise to you. I try to set up 3 servers, set up your database server behind a proxy server, and try to jump into the database server or try to access a database service. So you have MySQL running at a port on this database server with an IP, with a private IP address, and you try to connect from your local machine. So you have a Flask server or a Django server or a PHP server or a Java something. I don't know what Java uses for web services these days. But then you just put the local IP and port, say local host port something, and you could basically connect directly to this database server and make your code think that the server is actually running locally, right? So take that as an exercise. I will do the web server part, and I hope that you can repeat this with the database server. So again, only my proxy server has a public IP address. If we want to set up SSH into this proxy server, it's very straightforward. The first thing that I do is I go to my shell. So you can all see my shell. My username is McCall, and name of my machine is Penguin. We can check that SSH is installed, but we really don't need to. SSH always comes with Linux boxes. So if you go to USR, SBIN, well, that's a lot of results, and you try to grab SSH, you can see that we have the SSH daemon in there, which means SSH is installed on this machine. You can also check that the server is running. I think we generally have a server running. We can grab SSH here, and you can see that we have an SSH daemon running here, and I have a user agent running. I think I would like to kill the user agent so that I can demonstrate what role the user agent actually plays. Remember earlier I talked about channels. So I talked about SSH starting one TCP connection and multiplexing multiple channels over that single connection, right? So you have an SSH agent that does authentication, and you would have a separate channel for that, and then you will have a channel also for the actual shell session. And if you do port forwarding, you'd have a channel for that as well. So multiple channels are usually created with each. More than one channel usually is created when you set up an SSH connection. So let's kill this guy. Let's check that it's killed, and you can see that it's killed. I don't know why the SFTP server is running. I don't remember starting anything, but anyways, that is not important. So what I want to do now is I need to generate keys. So what I will do is, I think I've created keys earlier, so let me delete the keys that I created. So if I check, the way the directories are set up, there's a directory called, once you have SSH installed, you might need to install it if it's not installed, sudo apt install, I think SSH should install SSH, but usually you don't need to do that. If you have a Linux box, you can almost always guarantee that SSH comes with that box. The way the directories are set up, if you go into ls SSH, this contains your own private SSH configuration files, things that are personal to you, like the known host, for example. I can delete this known host file. It's just basically a way of saying, oh, I've seen this host before, I put it in this file. So your config is contained inside the home directory. So you can see that we are inside of our home directory. You can see the tilde here. And what we can do is we can see where the actual client and server configs are located. So if we go into ls etc SSH, you can see here we have an SSH config, which is the client config, and an SSHD config, which is the SSH daemon config. And you have further configuration here, expanded in here, and here, usually they're empty. These are directories that contain further configurations. Usually they're empty. And then you have keys. So you can see here, you have keys with different encryption algorithms. If you're familiar with encryption algorithms, this is elliptic curve digital signature algorithm. It has a private key and a public key. you see you have Edwards digital something 25519 key, public key, private key here. The ones without .pub are the private keys. You don't want to share that with anybody. But I can obviously show you what's contained inside the public key. So for example, let's go here and say SSH host. Let's look at the RSA one. So reverse Shama Adumen, that's the RSA cipher. It's an encryption algorithm. You can see what is contained inside the public key. What does it say? Sorry, I think I missed something. And then we have the pub. Right, so you can basically see this as the public key here. And it says the name of the algorithm that is being used is appended first, so that when you copy this to your server, which is the way you will set up access, the server actually knows what encryption algorithm we have, and then the user, and then the machine, right? So let's clear this. For us to set up access to the proxy server, we need to generate our own keys, a new set of private, a public key pair. So the way that works is with SSH keygen. So when you type SSH keygen, that basically tries to generate a public-private key RSA pair. So it's asking me to enter which file to save. I can basically use ID RSA. So it's trying to generate RSA. You can change the algorithm with a flag. I don't remember the flag, but you can actually use ECDSA or ED25519 or a different algorithm by passing a flag to the SSH keygen binary. But here, let's just stick with RSA. And then we want to enter a key phrase. I will explain why we need key phrases later, but for now, let's just pretend that we need the key phrase. Now my key has been generated. If I go in here, I can see the public key and the private key here, right? I can actually show you the private key, but I won't because I've entered a passphrase. So what the passphrase basically does is the passphrase encrypts the private key again. So you can't read, even if you have access to my private key, you still cannot decrypt messages that I'm exchanging with a remote SSH server because I've set up a, don't set up a passphrase, then anyone can use your private key to decrypt the messages that you're sharing. But basically your public key, nobody really cares. You can share your public key with everyone. I will share my public key with you. So let's do ID RSA.pub. And you can see my public key here. And you see here, it starts with SSH RSA, which says the encryption algorithm is RSA. And then you can see at the end, we have the key itself here. And then at the end, we have my username and the machine, my local machine. So the machine on which the key was generated. Now, what I need to do to gain access to the proxy server is to copy paste this here, copy paste my public key to my proxy server. Now, Google Cloud gives you a very handy way to do this. You might assume that this is a chicken and egg problem. If you set up a VM and you want to SSH into it, but you need to copy a public key into a directory in the server before you get access to it. Well, you need access to put your public key on the server. So Google Cloud provides a very handy way to do this. I think AWS has a similar way to do this as well. But there are ways you can do this if you have the machine physically. So if you have the remote server, if you have access to the remote server physically, all you need to do is copy the public key into a directory that I will talk about later as we go on. The directory is also on, it's in the .ssh path or directory on the server, and the file you want to look for is authorized keys. So what happens here is, I think I've added a few keys in the past. I'll just delete all of them since we don't need them anymore. So what I will do is, oh, I'm not sharing this tab. Sorry, I thought I was sharing the tab that you all can see. So I'm basically trying to edit the proxy server. And what I'm doing now, I can go back so that I realized I wasn't sharing. So I'm on the proxy server. I go into the proxy server and I basically say edit. And then I go in here. I can delete all of these ones. I don't need them anymore. and then I can try to add the new key that I've copied. I basically just add this key, and then I save. Now it's going to restart the instance, or it's going to restart the SSH daemon. Let's just basically roll in. Let's wait for that. And yes, we can go back to our proxy server to copy the IP address. And we can now SSH. We should now be able to SSH into the proxy server. So get back to the terminal. And if I say SSH that IP address, now I need to enter my passphrase. Now I'm on the proxy server. It's fairly straightforward. So this is the very most basic thing you can do, is just set up access to your proxy server using your public key. I talked about earlier that you have a chicken and egg problem here, because I first of all need access to the server to be able to copy keys, my public key, to the server. If I have a server, physical access to the server, I could just basically go into, if you go to ls SSH again, you can see here authorized keys, right? Now, if you cat authorized keys, you can see the same key that we copied earlier. This key, you can see here, right? It's basically the same key. You could visually verify. So what I could have done is I could have, if I had access to the VM, I could just basically go onto the VM, copy this public key file or this text here, and just copy paste it into this file. If I have a new key, all I need to do is just, I'll just say basically cat, assume this is the new key, and then I just basically write it to SSH hotkeys, authorized keys. Right, and that basically writes the new key, the new public key. So if I want to give access to a new user, I can generate a key for that user, or I have a new machine, I can generate a key from that machine using the current user that's logged on that machine, and then copy to authorized key, and that grants the user access to my proxy server. Okay, all well and good. We have access to our proxy server. Now, something annoying with passphrases you might have seen, now we're back to Penguin, so just pay attention to this here. This just tells you the machine we're on, or you could type woo to know what machine we're on. Oh, that doesn't tell you, but ideally you should. So what we've just done is we logged in to our proxy server. Now we've logged out from the proxy server. Now, if I try to log in again, you can see that I have to enter the passphrase again. Very annoying stuff. If I'm logging into multiple machines or I'm jumping from one host to another, I have to keep entering my my passphrase. I don't want to do that because it's annoying, and I'm lazy because I'm a software engineer. I don't want to do this. So what I do is I will start my SSH agent, and I will add my public key to the SSH agent. And then the moment I'm trying to add my public key to the SSH agent, what the SSH agent basically does is it loads my public key into memory with the passphrase, right? So you give the SSH agent your passphrase, and it's able to encrypt and decrypt your public key. And every time you try to authenticate, the SSH agent basically does the authentication for you. So you don't need to keep entering your passphrase. Now let's demonstrate that. I can run SSH agent. This is how you run the SSH agent. It basically just starts a socket. Let me actually run it so you see what happens when you run it. So it basically just starts a socket. You see, creates a Unix socket called temp. It's in the temporary file, which means it will be garbage collected eventually. Agent, and then it starts a process, and then it gives you the process ID. Now, if you PSAX this, you can see that SSH agent is running at 4605, right? So we already have the agent running. But I'm not sure if we have the SSH, let's see, what's that variable, hot sock. Okay, so we have this variable set, so which means our SSH agent is actually set up properly. So for us to add our key, we add the key, public key that we created in that directory. Remember, again, I'm on my local machine and I'm trying to add this key. It says no such file. Why is it saying no such file? Error connecting to agent. So the agent has died. Let's try to recreate the agent. Say SSH agent. All right, so we have a new agent running at 4610. And let's try to add our key. Now it's asking me for the passphrase. I just enter my passphrase. And then it tells me that the identity has been added to the SSH agent, which is running and has loaded my public key in memory. Now, when I try to log in to my proxy server, you can see now I don't need to enter my passphrase anymore, right? If I log out and I log in again, I don't need to enter my passphrase anymore, right? And this is basically will be reused as we go on. If I try to jump into my web server, which I'm going to do now, you see that I also don't need to enter my passphrase. But there's a trick here. How can I log into my web server since it doesn't have a public IP address? So if we go back here, you can see that I've used the external IP address of my proxy server to log onto the server. I've not provided a port because by default, SSH runs at port 22. We can change the port. You could do that by going into your server configuration. So if we go back into the server config, I talked about a client config and a server config. And I did say that in the .ssh file, you have personal configuration. You can override the default configuration, but the default configuration is located in etc sshd for the server. So the server is running on the proxy server and the client is running from my local machine. Now, it's a file, so I cut this. If I cut this file, you see somewhere there should be 22. Even if there isn't, it's just assume you see here port 22, but it's commented out, right? It's commented out because is that a comment? Okay, that's someone trying to join. It's commented out because by default, if you go to cat etc services, you can see that port 22 somewhere here is reserved for SSH. Well, let's just do grep. There's no point searching. All right, so you can see that port 22 is already reserved, right? So, but you can override that in your server. It doesn't have to be 22. So some things that some sysadmins do is, since most people know that the server, if you get access to a proxy server or just any machine at all, you know that SSH the daemon will very likely be running at 22. What some sysadmins do is they do security by obscurity. So they start the server at a different port, which means that if you are trying to hijack a machine by going to port 22, you'd have to scan all of the ports on the machine. It's like 65,000 ports, more than 65,000 ports. And that would take you a lot of time. So they pick a random port, set the server up there. That sort of gives you some security, but it's basically security by obscurity. If someone is able to port scan and eventually find the SSH, the port the SSH is running on, it doesn't make any difference. But again, you can override this setting. This file has lots of settings. You can override away as you go. I'm not going to go into all of the settings. They are documented in the if you go to man SSH, or if you go online, you can find what the different things does. I think importantly here, I can call out that we've disabled password-based authentication. So you see here, we say password authentication, no. So we don't want to use clear text passwords, right? We don't want to log into the remote machine using a username and password that runs that's available on that remote machine. We always want to use public key cryptography. There's other things that are being disabled. You can also authenticate via Kerberos if you're familiar with Kerberos. X forwarding is set to yes, which means we can forward an X terminal. Client keep alive should be set somewhere. It's set to 120, right? So it basically tries to keep the connection alive for as long as this duration. I assume it's in seconds. I'm not sure. So that's 2 minutes. Yeah, and that's basically it. So you can override the settings, you can add more settings, change stuff. Use DNS allows you to do reverse DNS. So currently I'm using IP addresses to gain access to the SSH server. But if you want to use a domain name or an host name, first of all, what use DNS does for you is when you convert the host name, when you consult a DNS server or a name server and you convert the host name to an IP address, you check that the IP address in the PTR record, so there are different records if you're familiar with DNS records. In the A record, if it's an IPv4 address, the host name is bound to an A record. Use DNS basically checks that the same host name that's bound to the IP address in the PTR record, the IP address is bound to that same host name. So that way people cannot spoof your IP address. So if someone installs an intermediate name server and you're trying to SSH into your machine using an host name that you're familiar with. So let's say you've set up your server using myserver.com. That's the host name you set up for the IP address, right? If someone tries to hijack or set up an intermediate name server, and they try to point that host name to a different IP address, use DNS to basically check that the IP address itself points reversibly to that host name, and that basically breaks, which means SSH will not log into it. But again, you always know that DNS is a point of failure if you're a systems admin, and if you can avoid using DNS, always avoid using DNS. So I'm using raw IP addresses here, but you can't always avoid it. Max startups, I will explain what that does much later. But in the interest of time, let us log out from here. So we've just seen how logging into a machine works. Very simple, basic stuff. Let's go back to our web server and try to copy paste again the host, the local machine's public key. Let's just do it manually again. .ssh ID, RSA.pub. I copy this. So this is how I log in to that remote machine. Do this again for the web server. It's going to take a bit of time. So edit this. And then we go to the SSH part. Delete this key. We don't need that. And then we save. So again, if you have access to this physically, you can go into .ssh/authorized keys on that machine, on the web server, and you can just copy paste that public key in there. That gives you access to that machine as well. But pay attention that this machine is running inside of an internal network, so it doesn't have a public IP address. So if I try to SSH to this, so I can actually copy this directly, right? So if I try to say SSH like I did with the proxy server, it just goes on and on trying to find that IP address. Eventually it's going to fail because it's not going to be able to find that IP address. So it just keeps rolling and rolling and rolling. It should have failed by now. It should have timed out. It's not timing out, but it would just basically fail to SSH into that machine because the IP address is a private IP address. It is not a public IP address. You can wait. That is supposed to have timed out. It hasn't timed out. I don't know why. Let's try it again. You can also configure timeouts in your client. There should be a way to configure timeouts somewhere in here in the client. So if you go into the client's config, so not the SSHD config, but SSH_config, there should be a way to configure login grace time, I assume. Probably not, or maybe 2 minutes. We're not going to wait for 2 minutes. Anyways, that fails. So what I can do is I can log into the machine with the public IP address. Remember, again, this is my proxy server. So proxy server This is it. And I get on my proxy server. Ideally, I should be able to log in to my... Can anybody tell me why this failed? So the public server, if we go back to our network configuration, you can see that the public server and the web server are basically on the same network. If you're familiar with networking, if you click on this network interface here, you see that we have the internal IP address is 10.154.0.2. If we go back, you see that this is 10.154.0.3. So essentially they're on the same network. But how do we know that we're on the same network? If you go to the subnetwork, click on it, you can see that the subnetwork has an IP range of this. If you're familiar with CIDR, how CIDR works, if you convert this into the range of IP addresses, this is basically 12 bits from the end. So we have 8 bits here. So this is 20. So the range is 20, which is 32. The address is 32 bits. And we have 12 bits left. We start counting from behind. So we have 8 bits here and we have 4 bits here. So we're going to have 0 to 15 on here, and then we have 0 to 255 on here. You don't have to do the math yourself. You can actually go to some website and say CIDR to IP range. Share this tab instead. If you come here, if I copy this address here, calculate, you can see that the first IP address starts from 0, 0, and the last one stops at 255.15. And you can see that both of them are within that range, right? So this is how you know that they're both on the same network. They're basically on the same subnetwork, right? So ideally, I should be able to go from the proxy server to the web server, but this says it has failed, right? It says public key has failed. What does that even mean? Now, this is where debugging now starts. So if you want to debug, there are 2 ways to do it. You can have an option. So all of the things you have inside of this file are called are basically options, and you can override them using the -o and say log level. So in this case, we want log level debug, and then we copy that IP address again, and then we actually see what is going on behind the scenes, right? So this is going to speed out a lot of things. So I will go over this later, but for the sake of this debugging session, we basically see that I'm trying to authenticate as myself, Nicole. I haven't provided a name, so it basically tries to use the same username on the current machine. But then we haven't copied. We haven't copied the public key from this machine. Remember when we showed the public key, at the very end you have username at machine, but we don't have Macol at proxy server. We don't have a public key for Macol at proxy server copied into the authorized keys for the web server. So if you go into authorized keys for web server, you're not going to find Macol at. So let's actually go in there very quickly. I feel like I'm taking a lot of time doing this, but I hope it's useful. If you go here, my SSH keys, and scroll to the end, you can see I only have Macol at Penguin, which is my local machine, the machine I'm actually working from, right? The only key we have here is Macol at Penguin. Now, the way that I can do this is, since the web server actually recognizes Macol at Penguin, one of the things I can do is I can log into the proxy server and forward my credentials through the proxy server to the web server, and I will gain access to the web server. How do we do that? We just basically tell the agent to forward itself. So the SSH agent, remember, is running on my Penguin server, which is my local machine. It's running locally. So if I PSAX again, you can see that I have SSH agent. The new one that we started is 4610. It's running here. Now, what I want to do is I want my SSH agent to be forwarded to the remote machine, which basically takes the SSH agent and its memory content, which is my public key, forwards them to my proxy server. So when I'm on the proxy server now, I can now present that public key and use that to authenticate to the web server. So let's quickly do that. So I have this, my proxy server, and what I need to do is add the O option and say,
sorry, you're still sharing the cloud console.
Oh, sorry. Yeah. So this is basically what I'm doing. So when I said I checked thank you for calling that out. When I said I checked that the SSH agent is running at just PSAX, I see SSH agent running at 4610, and then I say, so proxy server with forwarded agent. All right. Now I've logged into my proxy server. If I PSAX here, it doesn't actually tell me that the agent is running. I don't see any agent running. But then if I try to log in to my web server, now this works. So I don't need to copy. I mean, another way to do this, you could do this another way if you want. You could do this as an exercise. You can try to run SSH keygen. So let's go back to our proxy server. If you run SSH keygen on here and generate a public and private key pair, if you copy that public key to your web server, you don't need to forward credentials. You basically don't need to forward the agent, right? But in this case, since we haven't set up SSH access from the proxy server to the web server, but I know that Penguin, which is the machine that I've originally SSH from, has access to the web server, I can basically forward the agent as I go through proxy, and that allows me to go into web server. So I'm 2 layers deep now. Think of Inception, right? So I'm 2 layers deep if I do this, right? So basically, I'm inside of a private network already, right? So I'm no longer on the public internet because this machine here, you can see, is running on a private network, which is the IP address. You remember earlier, I said that this IP address is private. It's inside of a subnetwork. So far so good. We've managed to see what SSH agent does, and we've managed to see how we can debug stuff. If we wanted to start a web server on this web server, so currently we don't have any web servers running. It's just an empty Linux box. I can start a web server on here and then try to make my local machine think that the web server is actually running locally. All right, so let's try to start a web server. If you're familiar with Netcat, you could pretentiously set up a listener. So Netcat is NC. The flag L basically says listen at port 80. So start listening. So the way HTTP servers work is you set up the server, and then you pick a port, which is usually 80 or 8080, and then you bind to that port and you start listening on that port, so that when traffic comes in through that port, the server basically responds through that port back to the client, right? So what we're doing here is I have a web server and I'm starting. It says permission denied. Can anybody tell me why permission is denied? Ideally, this should work, but permission is denied. Just Poker, Unix, if you're familiar with Unix. Okay, I'll just quickly give an answer. So for you to use a port that's less than 1024, you need to be root. So ports that are less than 1024 are reserved ports, right? So for you to be able to use them, you need to be root. But you can take ports that are higher than this. So if I sudo bang here, I should be able to listen. But that's not what we start listening on port 80, which is the HTTP port. I see lots of people leaving the meeting. I hope it's not too complex. So now remember, we're still on web server, and we've gone to web server through our proxy server. Follow me. Now I'm back on my Penguin, right? And I have an HTTP server running here. Now I want my local machine to think that the HTTP server is running on my local machine, which is Penguin. Now the way that I do that is I forward the port. I can forward a local port to the web server port. Remember that the way that we got access to the web server is through the proxy server. So I basically can't go to the web server without going through the proxy server. So the first thing that I need to do is I need to jump through the proxy server into the web server, which is on a private network. And then I need to tell SSH to forward ports. And the way we do that is SSH, I'm saying jump through my IP address for this again. It's this. So I say SSH jump through this. And I say you're going into this. So the machine we want to SSH into where the web server is running is this, this. And then I say forward my local port 8080. I will explain why I'm choosing 8080, but you can use any other port. And then I say localhost. And then I say 80 as well, which is where my web server is running. Right, so localhost in this context. So the port forwarding supports the syntax. Basically, is this. Let's cancel this. Control C. If I go to man SSH, and we try to see what J does. So J basically tells you to connect to the target host by first making a connection to the jump host described by destination. So that's what J does. So we'll go through the proxy server to reach the web server that doesn't have. Yes.
Can you switch the tab?
Can I switch the tab? Oh, sorry. I feel like people need to stop me if I'm talking and it's not coherent with what you're seeing on the screen. So what I'm trying to do, okay, let's quit this. And what I'm trying to do is I'm trying to jump through my proxy server to my local server, which is running a web server, or at least it's running a listener, an HTTP listener on this side, which is still running here on a different tab. And what I'm trying to do is jump through the proxy server, which is this syntax here, and then forward my local host, this port on my local machine to localhost 80. Now this localhost, this part here is interpreted as the local host on the final destination machine. So the reason why I've run SSH is so you can see what all the flags mean. So -J, which is how you jump, connect to the target host by first making an SSH connection to the jump host described by destination, which is our proxy server. And then -L, which does local port forwarding, should be somewhere up, not down. It's basically bind address, port, host, and host port. You can drop the bind address if it's a local port. You can also use a Unix socket. So you see here, local socket, host port, or local socket, remote socket. So you can also use Unix domain sockets to set up connections. But in this case, we're using ports. We're using IP address and port. So which is the bind address. We can skip bind address. So the curly brace here, or the angular brace here, means it's optional. So you can see here, means we can drop it. So since we're sure that we're connecting from localhost, what I can do is basically just drop this localhost here. And then I'm starting from my port 8080. And then I'm going to localhost 80. I've seen a question there. I will take it. Just let me run this command. I don't want to enter my passphrase. I just say -O forward agent, and I say yes. I don't know why it's asking me to enter this, but let's enter it anyway. And then I need to add this. Now, the thing with having a host that you don't know is you should always verify the fingerprints. I'm not going to verify here because of time, but this fingerprint here is the fingerprint of the public key of my remote host, of this host here, right? This 10.154.0.2. But let's do that, yes. And then I need to enter my passphrase again because I'm going through two machines. And then that jumps me into the proxy server. But for some reason, we should be on the web server, but we're not on the web server. Why is that the case? Let's see. So permanently added this. Let's try that again. So we shouldn't stop on the proxy server. We should stop. Oh, yeah. OK, thank you. So it's not .2, it's .3. All right, that's a good catch. All right, let me take the question before we go on. If, for example, we connect to the web server directly from local, we can skip. Yes, if the web server had a public address, a public IP address, you can skip jumping. But in this case, we need to jump because we need to enter the network, the subnetwork first, and then go to the web server. But if I understand the question correctly, we connect to the web server from local, we can skip. If we're on the proxy server and we want to go to the web server, it's just one hop, so we don't need to jump. If I understand the question, you can also mute yourself if you want to ask directly if I've not answered the question. All right, I'll just go on. All right, so click on this. Yeah. You have a raised hand. Do you want to ask a question? All right, no questions. So let's enter passphrase. So we only need to enter it once. And now you see we are on the web server and we're forwarding traffic. So if this command works, it means that we've jumped through the proxy server. So you see in the initial case, we need to forward agent, go through the proxy server and reach the web server, which means that commands that I'm entering here are still visible to the proxy server because the proxy server is the intermediate connection. In this case, it's transparent. The proxy server cannot snoop on my traffic. It doesn't know because it's basically a jump host. So it doesn't even know what's happening. The connection is encrypted across the jump host, right? So it doesn't know what we're doing. The only thing that we've done here is we jump through the host and then we forward AT to localhost where my web server is running on the local machine here, and we have a web server running. Now let's go back to our browser and try to access localhost. I think port 8080 was what we used. Yeah, port 8080. So let's share this tab instead. Okay, I hope I'm sharing the right tab. Yes, I am sharing the right tab. Surprisingly, you can't see my browser tab. Why is that? Maybe because I'm not sharing the window. Okay, let's stop sharing. And let's share the window instead. Because that lets you see that I'm not actually making stuff up. I mean, I know that you trust me, but hopefully you can see that now. Yes, now you can see the tab. So can everyone see the new tab? I assume that's a yes. Okay, cool. So if we go to localhost 8080, now you see that now we need to jump back again. Okay, so I think this was not a good idea. Let's just share tabs instead. If we share tab, let us share the new tab. It's running here. Now we've requested 8080 on this tab. It's still loading, but then if we go back to our web server, you can see here that if you scroll down, my web server just told me where I'm running NC. So remember the last time, the only thing we did was run sudo NC listen on port 80. And now it's telling me that a request is coming in from Google Chrome, which is my Google Chrome, from Chrome OS, which is my operating system. So, and the local host is 8080, whereas the server is running at 80. Now, this is a very good way to if you have a development setup where you have an HTTP server in a dev environment. Now I said HTTP, not HTTPS, so you don't have Nginx and all of the SSL things or TLS things installed yet, and you still want to guarantee a secure connection. Now I've used 8080 because I'm just assuming now, I take for granted that the connection is secure, so anybody cannot snoop on the traffic between my local machine, which is Penguin, through the proxy host to the web server. So even if the protocol says HTTP, it's not secure. The connection or the traffic between the browser and the web server is actually secure now, right? So let's kill this stuff and let's actually run a small web server. Copy paste code for web server. so that when NC listens on the port, on port 80, it can actually respond with something. So let's copy paste this. Now, this is bash. If you're not familiar with bash, I have a while true and I have a do cat with an end of file, which means instead of cutting a file, I'm just basically pasting the text in line. And I've copy pasted an HTTP response. So this is a typical HTTP response. You have the 200, which says, yes, it's an OK. And I have the server name and then the content type and then the actual content. This is how you construct an HTTP response. I'm not going to go into that. And then I have a pipe. I'm feeding that to my NC so that when someone sends a request to that port, while I'm listening on that port, I respond with this text here, right? And I'm running it in a while true because I want the server to keep running. So after I respond, if someone requests again, I want to respond with the same response. And then I run it in background with the ampersand, right? So let's start this. Oh, it still says permission denied because I'm trying to run at port 80. Let's try to run at port 8000, which is greater than 1024. I don't want to sudo. And that should basically, I think I messed up something somewhere. Oh, yeah, I have an extra $sign. So let's copy paste this. And then run this. It says nc command not found. So sudo apt install netcat. And netcat is now installed. Paste this. And then my web server is now running at 4721. So that's a PID. So take for granted our web server is now running, but now it's running at 8000, which means I need to close this. So you can see channels are open filled, because the web server is still trying to get content, but since the server has died, the channels are now basically refusing connection from the browser. So what we need to do is back out of this and then recreate our port forwarding, instead forwarding to port 8000, which is the new port, share this tab instead. So which is the new port. So we go from 80 to 8000, which is the new port that our web server is running at. And then I don't know why forward agent isn't working. Anyways, we have our web server now and we forwarded ports. If we go back to our browser and we try to read local 8080, why does that not work? Oh, sorry. I think the mistake is that I started the server on the wrong machine. So I want to start the server on the web server itself, not Penguin. So let's kill 94721. Let us go into a proxy server and then we need a forward agent. Or we can actually copy paste the code here. We can also copy paste the code here. Start the proxy server here, or start the web server here. And then it's running at a new process. So if I go back to my web browser and I try to access stuff here, I should see I'm serving from remote machine via local port forwarding. Can everybody see this? Right, so basically it looks like my web server is running locally, but it's not. It's running on a very far away machine. And you can see here the HTTP request given to the server. If I refresh this, again, we're running it in a while loop, so which means that every time we request, it just responds with the same thing. In the interest of time, I have 7 minutes left. I might have to go over time. I thought I had a lot of time, but again, live demos might take longer than you expect. We can actually do the same. So as an exercise, you can go back, which is actually quite interesting. You can go back now, and instead of running your web server remotely, try to access a web server that's running on your local machine. So start a web server on your local machine and log in to your remote machine your remote web server now, and try to access a web server or a service that's running on the local machine from that web server or that remote machine. The way you do this is remote port forwarding. So I just basically change this L to R, right? And then I'm forwarding port 8080 from the remote machine to localhost on 8000. So I need to start a web server on 8000. If I go to my remote machine, I'm jumping through the proxy server, remember? I could basically also view HTTP content from there. And again, the connection is very, very secure. I won't be able to go into dynamic port forwarding. I leave that as an exercise, but it's very, very powerful. It's the way that if you have, the way we've set this up, let's say you have a load balancer, which is also a proxy, and you have multiple services or HTTP services running behind that proxy, you can set up a SOX proxy such that you just, with one port, you just have specify one port on your local machine. It's a very simple command. You just say -D one port. It forwards traffic from that port to the remote, to the proxy server's ports, and then the proxy server does all of the DNS, all of the, it just basically routes the traffic to the right HTTP service. It takes time to set up, but once you set it up, it works like magic, right? One of the interesting things, use cases I found for this is, assume that you set up the database server running on that database machine, and then you have a port and IP you can access it on. Now on your local machine, you have code that's running. So you have Python or Flask. You could basically set up port forwarding to the database service running there. And you could test code on your remote database by making local machine think that the database is running locally with port forwarding. All exciting stuff. Yeah, we have just shown how local port forwarding work. I said that you can also do this in a reverse way by doing -R instead of -L. I've talked about how you can do this for multiple services by using -D, which is dynamic port forwarding. That basically sets up a SOX server, and you need to be able to, if you want to use this with a browser, you have to tell the browser to use a SOX, to connect via a SOX proxy, and you specify the ports that you're bound to on your local machine. Very quickly, I will go back to the slides. Oh, I won't go back to the slides. I'll just continue my remote stuff. One of the things that I wanted to talk about was what actually happens behind the scenes with SSH, which is the internal stuff. And we only have 4 minutes left, but I will go over time. Apologies for that. I might need, say, 20 more minutes to go over this. Let's start with the very basic SSH to the proxy server. Now, if I want to log, I said I can change the log level using -O and saying log level. Setting that to debug. But a simpler way to do this is just -V. If you're familiar with flags, it's verbose, right? If you add more V's, it does more debugging. If you add more V's, again, it does more debugging. I think this is useful in cases where, let's assume that you have 3 proxy servers, right? So you do SSH. So remember we did, let me do this and then back out. Remember we did SSHJ. If you have multiple jump proxies, you can basically specify them by comma, say next proxy, and then another proxy. So you could jump through proxies, jump through hoops before you reach the final machine, which is, I don't know, in some deep machine far away inside some private network. Before you use port forwarding, check with your org policy because it may not be allowed. It's a way to enter a private network without actually having access. Your local machine may not have access to the private network, but you're basically granting it access to the private network using the proxy that you have access to. So you always check with the sysadmins in your org if this is allowed. So you don't get terminated or exterminated by your company. It's a very powerful thing, but it does open a new port inside of the private network. But again, it is secure, so you don't have to be worried about someone snooping on your traffic. So what we tried to do was to see what actually happens behind the scenes with SSH by going to verbose. If we go to verbose, it tells me to enter key phrase. Again, apparently I should use this instead because the SSH agent is running already here, so I don't have to enter this every time. So let's try to SSH into here, make this verbose. Right, so I'm on my proxy server. Logged onto my proxy server, and using debug one, everything we talked about earlier, you can see the first thing it does is it goes to read the client configuration data to see how to set up the client. And then it tries to pick the identity file, which is IDRSA. So the hit is 0, the misses are -1. So when you see a -1, it means it didn't find the file. So it finds IDRSA, which is our public key for RSA. And then it uses that to start communication, and then it does key exchange. When it finishes key exchange, it picks 255.1.9/256 on a local machine. And for the host key, it does ECD DSA SHA-2. So we talked about how you have different algorithms. One algorithm, RSA, which is actually what we use for the key exchange. And then we have an algorithm that actually does the symmetric encryption. And then finally, we have MAC, right? So you see SHA-20 is a MAC algorithm. It's a message authentication coding algorithm. And you see that the cipher it selects from server to client is SHA-20. And then from client back to server is also SHA-20, right? And then you go on and on. I was going to talk about the fingerprint for the host. If you go to your proxy server, this is the host key here. You can actually verify that this host key is correct. You can see it ends with 01. If I go to my proxy server and I say SSH key gen, I think the flag is PF. I don't remember. And I go to SSH. I'm basically saying generate the fingerprint for my IDRSA file. I don't remember this. Oh, this basically generates a new, oh, damn, I've done the wrong thing. What I'm trying to do is print the fingerprint. But if you try to print the fingerprint, because the fingerprint is not the public key itself, the fingerprint is a much more readable version of the public key. But I'm just trying to check that the fingerprint is the same as what was presented by the server here. So it says the host key is this. All right, so this is the host key. This is my own key, right? This is the fingerprint of my own key. This is the fingerprint of the host. The host is using ECDSA SHA this. I am using RSA. So you see that you may not use the same algorithms across both ends, right? So the host is using SHA-2 NISTP 256, and I'm using RSA 256, RSA SHA 256. But basically the way it starts, you've seen, is that you first of all negotiate. We talked about, we go from public key cryptography to symmetric key cryptography encryption, which happens here after you do key exchange. So you start key exchange, you have a message that says initialize key exchange. Both of them acknowledge we want to do key exchange. They do the key exchange, and then they pick an algorithm on the local machine and on the host, and then they also negotiate how they want to do MAC encoding or MAC encryption, right? And then you go on and on and on and on, and then the more options from your authorized keys. You check that the host is actually in the authorized keys, on and on and on and on and on and on like that. Like, we can go back outside and try to print more data to see more stuff. So debug 1 was the things we saw before. Now we can go to debug 2. You see debug 2 messages print more things. So now it tells me that the host name is this address, and it tells me I'm connecting to port 22. Remember, we don't specify the ports, but since the port, the default port for SSH is 22, now it's telling me that we're going to port 22. Now debug 2 messages, this is not interesting. File descriptor is 3. You will see why file descriptor is 3 later on. There's so many things. I think the main use of this, if you're just SSH into one machine, it's not very useful to print debug messages. When you're doing very complex stuff, like you're jumping from one host or 3 hosts, and then something fails in between, it's usually useful to print debug messages, because that's how you find out what broke where, right? If you don't print the debug message, the SSH client just tells you, oh, this thing didn't work, and that's all you get. But the more you debug, the more you see stuff printed out, and the more you can get access to debug what actually happened. You can see what failed, what didn't fail, and then you can use that to find out the root cause. So if we go back to this and we try to access the private web server. I think I can find the IP now. But if we try to access the private IP address of the web server going through the host, remember, if we don't forward the agent, that fails. If we debug, it actually tells us why that failed. So it basically tells us that the public key we're trying to use is not accepted on the web server side, which tells us it's a public key problem. So debugging is a good way to find out what's broken with your service. Another thing that I found useful in the HINADs, this is a lot more complex, but it's fun stuff, is you can strace. If you're familiar with strace, you're basically finding out all the system calls that happened when you try to perform a shell command, right? So we're trying to strace, and what I'm doing here is I will output to a file. So we'll see what's printed to that file as we try to SSH. So we see all the system calls that happen when we try to SSH. So let's print this to temp SSH trace.text. And then we run this. Well, that failed for some reason. I don't know why. I did say output file. Why did it log me out? Let's see. So stracing, and then, oh yeah, sorry. The output command is not for SSH. It is for strace. So that fails. So SSH thinks we're trying to pass an option because -O for SSH means option, but for strace it means output. So it means output file or output path. So let's say SSH strace dump.text. And now if we try that, that should work. Yeah, so now we're on our proxy server and that works. If we try to go to this file and see the contents of this file, so let's open a new tab, and then we cut this here. You could basically see if you want to go through Linux stuff, you could literally just see everything that happened here, which is similar to debugging, but here it's much more closer to the code, right? So it's closer to the C code. You basically see the first thing, the entry point into all of this is just basically execv. So you start from the binary with the IP address, and then you execute that at an address, and then you break, access, do some preload, all of this is not interesting. I think the interesting bits, all of this is just memory map, open file, close file, memory map. I think the interesting bit is where we connect. So if you're familiar with syscalls, I think the connect pact is the interesting part. So all of this is not interesting. It's just basically trying to do something with NSCD, which is not interesting for us. In any case, the operation fails with -1, it exits with -1. In Linux, when you make a system call and when you make a call and it has a non-zero exit code, it means it failed, and it failed with no such directory. The one we're interested in is this one. So connect 3. Remember earlier I talked about a 3 in your debug code where we were doing something with 3 somewhere, right? We're trying to do something with 3. I don't remember what I said with 3, but I do remember saying something with 3 in here. In any case, there's a file descriptor. So connect 3. So connect, the signature of connect, it takes a file descriptor, it takes an address, and then it takes an address size. We're basically trying to connect to this host here, which is the IP address. It's the address family is an INET, which is an internet address, and then it connects to 3. So we'll see. We'll go back to the file to see how 3 was set up, and then again we have a connect 4, which is another file descriptor for my agent socket. So remember I said earlier that we have multiple channels. One channel for the session, one channel for the agent. You can see here we have a unique socket that's backing the agent, and that agent, when you forward the agent, you're basically using that unique socket to pass on or communicate with the remote machine to forward credentials. right? If we go back to the file and we try to find this line, we can start from there to see all of the interesting things that happen when you try to SSH. So let's go back and try and find that file. There's a connect somewhere, it keeps going up, 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 and I think we've hit this. Now, this is the line. So the first thing that we do, if you go back, you see we try to set up a socket, an internet socket, IP TCP socket, and the file descriptor returned is 3. Now, the way file descriptors work is when you try to create a new file, it returns the next number. So 0 and 1, you remember, are standard input, if I'm not mistaken. So 0 should be, 1 should be input, 1 should be output, 1 should be error. I don't remember, but 0, 1, 2 are probably already taken. Anybody can chime in, but the next file descriptor that's available, integer, is 3. So we take 3, and then we do some control on the file, which is basically close on execute. So once we execute something on the file will close automatically, and then we try to connect. We try to connect to the socket. And then we set the socket option, which is keep alive. Remember, inside of our config, there's a thing called keep alive inside the config, but also TCP has a thing for keeping alive connections, right? So this is probably the TCP part. And then we try to get the pair name. We try to get the pair that we're connecting to from the local machine. Now, remember that the socket is a local socket. So the socket is local to our machine. And with the local socket, we try to connect this socket 3, which is at the file descriptor 3, to this address. And it returns 0, which means it succeeded. We try to get the pair name. The pair name is returned inside of this pointer. This is a pointer. So this returns an integer, but if you're familiar with how C works, you can have pointers that you populate buffers, or you populate a pointer with a value. So the return pair name is this one. This is called twice. I don't know why. The port we're connecting to is 22. We try to get the socket name and our own IP address. So my IP address is this. So remember how TCP works. I told you earlier that, TCP, you set up a tuple of source IP, source port, and then destination IP and destination port. Now I can actually verify that all of this is correct by running another command. If you're familiar with list of files, ls of I, you can see here that there are 2 TCP ones. The ones that I started that's listening to, remember I started an NC on my local machine. I'd intended to start it on the web server. So we have NC running at port 8000. And then I have SSH, which is also using TCP, running at port 39070. If you go back here, you see 39070 here, and then you have the IP address. Now here it's masked. I can actually get the IP address by telling it to just return, I think ls of, I don't remember, I think n is the option. Yeah, so n is the option. And you can see the IP address, my local IP address, my local port, and then the remote IP address. And then, well, it doesn't tell you the remote port. I don't know why. That should be 22. For some reason, it doesn't say 22. It should be 22. In any case, it says the default SSH port. We know it's 22. And it says the connection is established, right? So if we go back to our code, you can see the get socket name actually works. And then we go on and on and on. And all of this performs operations, opens the ID RSA file, the identity file, tries to read the identity file. Before it does that, it goes into etc password. I think it does this. If you know what etc password does, it basically contains your user ID, encrypted password, directories, blah, blah, blah. I think it's trying to construct the home directory for the user McCall, right? And then it opens that at file descriptor 4, and then you close the file descriptor 4, so you can reuse 4 now. So you open the identity file at 4, on and on and on, and then you try to read that file. So you begin open SSH private key, which is a private key file, and then on and on and on. You open the public key file as well. You read that, and then you pass that on to start your cryptography thing, and then on and on and on. A couple of things fail. You try to open stuff, they fail. They're not necessary because you already have your identity file here, and then on and on and on and on and on. All of this fails. All of this fails. And then you have your banner message, right? So you start to write stuff from the remote server, right? So at this point, you've already logged in, and then you perform more operations. You try to add the host to non-host, If you want to do this yourself, you could spend the whole day looking at this. If we run a command, for example, I think this is where we started at strace. Yes, this is where we started at strace. So if I say echo, now we're reaching the end, ego B, and then I reopen my file. You can see somewhere we are writing ego B. So we're doing a system call ego B, and somehow it knows how to forward. So you know that this is a remote shell, but the system call happens, what is happening sort of locally. It looks like it's happening locally, right? So this is basically how SSH works, right? So it's basically taking commands from my remote shell, taking them to the remote machine where I've SSH'd into and running those commands. They're executing them there. So this is basically the logic behind remote shell execution with SSH. If you have the time, you could spend the whole day running through all of this. I think an interesting task you can do is try to restart the daemon. Now, we're only doing this on the client side because remember we called the strace command. If we go back here, we called so this is where I ran ego B. We ran the strace command on the SSH client. So if you go to your proxy server and you try to restart the server using strace, so try to do strace or pkill, strace pkill -1, the SSH process, SSHD, it restarts it, but with strace tracing the system calls. You could basically see how you're making system calls on the side, and you're making system calls on that side, and you're forwarding commands back and forth between both machines. I think I've run out of time. I was hoping to get more time for this, but I will skip all of the other things that I plan to show. We can have a new session if people are interested in this, but I feel like this is very, very technical, and a lot of people I might have lost a lot of people already. All right, let's go back to the slides and finish up. So pitfalls and recommendations. Never, ever, ever enroll your own crypto algorithm for use with SSH. I feel like this is a command that happens to work for every other thing, not only SSH. So if you're doing anything at all, you're trying to set up an HTTP server, you're trying to set up a TLS offloading server, you're trying to set up a proxy, you should never, ever, ever enroll your own crypto. So use the standard CIFARs that we already have, which is RSA, ECDSA, ED25519, or any other one that's already been developed, because these are battle tested. They've been tested multiple times, and new ones are being rolled out every day, and old ones are being phased out. The thing with encryption is you would reach a point where an encryption algorithm becomes, the whole point of encryption is that it would take forever for anyone to decrypt it, because working with prime numbers, if you're familiar with how encryption works, right? So if you have sufficient compute power, let's say you have planetary compute power, you have access to all of Google's machines, you could probably in real time decrypt something with a weak encryption algorithm. But let's assume you have all of the machines in the world, you probably wouldn't even be able to decrypt with some encryption algorithms. It would take you years to decrypt, and by that time I finished communicating. This is the whole point of encryption algorithms. It just makes decrypting the message invisible in real time. Never hand out your private keys. We talked about that earlier. Your private keys are supposed to be private. You can give out your public keys. That's why the file is always having the pub as the extension. The one that doesn't have the pub is your private key. Never hand that down to anyone. If you want to be double sure and you don't want to make mistakes, when you set up the private key, make sure you have a passphrase, because if you eventually hand it out, you can be sure that it's still useless, because the private key is also encrypted because you've set up a passphrase, which is what the next point is saying. You can set up passphrases on your client private keys. You probably don't want to do that for the server. You can do that for the server as well, but the problem with that is that every time you try to set up your SSH daemon, since the daemon will try to load the keys, because you remember when the client tries to connect, the server needs to present its keys. So you see the fingerprint of the server presented. The problem with setting up passphrases on the server side is every time the machine restarts or SSH daemon restarts, you need to enter the passphrase before the daemon can actually proceed. So which means the daemon will almost never start unless you log into the machine and enter the passphrase, and you don't want that. So you could skip that for the server. But for the client, it's an important or interesting thing that you want to keep in mind to keep doing. Use port forwarding in compliance with the org's security policy. So you see that basically jumping from one host to another just because you've managed to install keys may not be acceptable. Now you can forward arbitrary traffic, any kind of traffic. Think of any kind of TCP IP traffic, even protocols that you invent. You should be able to forward them using SSH. Again, don't invent your own TCP IP protocol, but just saying if you have like a mail server, POP3, IMAP, you have, I don't know, a database service, you have some other service at all, you can forward them using SSH. Never grant root access. So if you go into the SSH config file, sshd_config or ssh_config, you see that root login access is disabled. What that means is when you drop into a remote shell session, you're logged in as a user. You're not logged in as root. You're never logged in as root because you don't want to give anyone root access to your remote machines, except you know what you're doing. You can decide to not use the default port 22, but that's just security by obscurity. Instead of that, you can instead use packet filtering to block or allow IPs or ports, whatever you want. I talked about the use DNS option. Use it with care because if DNS fails, then you're locked out of your SSH server. Remember to rotate your keys. So it's not enough to just set up your keys and leave them there forever. You can rotate them as a good hygiene. Rotate them, say, once a year, once in 2 years, I don't know. You can assume that at some point someone would get access to your keys. So it's always a good idea to rotate them. And then max startups. Remember earlier on, I showed us in the config an option called max startups. This basically means that if someone is if you've set up your server to log in with password instead of public keys, the moment you create a session, you have to log in to proceed with the session. But you've created a session already, and every session is basically holding resources on your daemon or on your server. Right. So if you have a case where someone who doesn't have access to your credentials basically creates 1,000 or 10,000 unauthenticated sessions, at some point you will max out. The server will max out on the number of sessions it can support. The number is finite, which means you yourself cannot create a new session. Right. So creating max startups is a way to throttle, start fading at a certain point so that you can get access if someone is trying to DOS your SSH server with using unauthenticated access. But anyways, this will not be a problem if you disable password login, because then you wouldn't have unauthenticated sessions. Finally, optimizations. You can multiplex using control master, control path. If you've noticed, as I'm jumping from the different tabs in my shell, you can see that I've created multiple connections to the same proxy server. And what basically happens is if you go to PSAX on the proxy server, you can see that there's different processes back in those connections, right? I can optimize by having a control master and a control path, which means that I'm only going to use one connection for the same connection tuple. So when I'm going from one source IP and port to the same destination IP and port, and I try to create a new SSH connection, it just reuses the existing connection. Now, this is good in a general case, but if you're trying to do X forwarding, which I didn't talk about, things start to get slow since you're trying to multiplex multiple things or multiplex multiple sessions on the same connection. If you're doing port forwarding and you don't actually need to run SSH, so which we've done in this case. Well, in this case, we needed SSH because I needed to start the web server. But let's assume the web server is already running and I don't want to drop people into a shell, which is always a good thing to do generally. If you always start from the principle of least privilege. You can use the FN option with the ampersand, which means run SSH in background, which is -F, and then -N means do not start a shell, so no shell session on the remote machine, right? Which also means you can shoot the user. You can shoot the user without worrying that the connection will break if it doesn't find shell. So when you drop into a remote shell session, SSH tries to start the shell program. If it doesn't find the shell program in any of your paths, your binary paths, it just basically fails. So the SSH connection or call will fail. But then if you start with N and you shoot the user into a directory where it can't find the shell binary, then it proceeds as normal. And then you can, this is a shameless plug, you can use a standard TCP proxy instead of using an Android proxy like I've done in my case. IPTCP provided by Google Cloud is a good one. I actually worked directly on this product. So again, this is a shameless plug. And the final slide, just references. SSH Mastery by Michael Lucas is a very good book. Lets you do many things with SSH, helps you harden your SSH server more than the recommendations that I've already given. And you can also go to the Wikipedia page for Secure Shell to learn more about that. Questions? And thank you for your patience. I've been ranting away for, yes, someone just commented, input is 0, output is 1, and error is 2. Yes, thank you very much. So the next file descriptor is 3. And that's why the first 3 are already taken, so the next one is 3. When you pick 3, then the next one is 4. That's why we get 4. If you keep going through all the system calls, you find lots of interesting things. It's a good way to actually understand more of the things that are happening behind the scenes and help you debug when you have failures, when you're doing crazy stuff. You can actually like proxy commands, SOCAT, like there's lots of crazy things you can do with SSH, but just time will not permit us to go through all of them, and you may not even need them in your day-to-day work. So there's no point going through them. All right, questions and answers? Otherwise, we drop the call. Go in.
I guess it was pretty intense.
I know. Yes, I know. It was when I started. I realized, okay, I think I'm going too deep now, and decided to. But I think the point of recording also is people can always go back and take it might take you, I don't know, hours to deconstruct everything we've gone through. But you can try to reproduce the things, try to reproduce the system, the calls that we make from the bash, from the command line, and then just try to break things apart on your own and try to understand how SSH works more.
Yeah, sure. Well, thank you, everybody. Seems there are no questions. I think Moses shared his Twitter handle, so you can reach. Yeah,
I'll share the slides with the organizers as well, and then they can share it more broadly.
All right, cool. So we'll share the slides and the recording as soon as we can. Thank you, everybody. Thank you so much. It was so lovely. Thank you, Moses. It was super. It was great, but yeah, like followed and it was yeah, but really it was super great. And if you guys want him to come back, or you want a second session or something, you can always let us know. Twitter, right? System assist design. So I have to put it there because it's at SY. Let me just share the profile. Copy link. Yeah, or you could send a DM to me. People who on the call know me, my username is Mazi Bio. Okay, good. They're already requesting, so we'll look into it. But yeah, you can resend a DM to me, or to in the bio of Sys Design, you see there's alternate wolf, there's me, and there's Chidi. You can send a DM to any of us. If you have suggestions, or if you have friends who you feel are pretty good at some things that would be hard to have as a conversation on the TL, but a class like this would really help. Please, we want ideas, so please send us your ideas. But yeah, thank you so much, everyone, for joining. It was a good one. Moses, thank you again. Thanks for the time.
All right, thanks everyone. See you all. Thanks for attending. Cheers.
Right. Have a great evening, everyone. If you're in Nigeria or in our time zone. Bye.